So we'll be talking about HDFS system, seeing what are the core components. We'll see the HDFS architecture. We'll see the daemons in Hadoop, and we'll see some of the hands-on commands which you can use in HDFS. How to write files to HDFS, how to read files from HDFS. All these things we'll be talking about today. So Hadoop components, I told you there are two. Core Hadoop consists of two components. One is storage and other is the processing. So storage part is the HDFS while the processing part is the MapReduce. So that is what is a core Hadoop consists of. So we need to first store the data that we do through HDFS and the processing that we do through MapReduce. The core components of Hadoop, if we see, then this is storage part. You'll see that these are there are two daemons, important daemons that are from HDFS, that is the name node and the data nodes. And on MapReduce part, there is the job tracker and the task trackers. We'll be talking about this in detail, and also what is secondary name node, that is one of the third daemon of the HDFS. So we have total 5 daemons, job tracker, task tracker, name node, data node, and the secondary name node. So one high-end machine will be made as name node, while the cheap commodity hardwares we are talking about in the cluster will be made as data node. So supposing in this example we can see 4 nodes. So this is a cluster which consists of 4 nodes, where this is the machine where master daemons are running, and these are the machines where the slave daemons are running. So daemons are some background processes or the JVM that are running. So these are the 5 major daemons of Hadoop, and these are the name node and data node, secondary name node, job tracker, and task tracker. So these are the 5 daemons of Hadoop. So master services will be running on these name node, and the secondary name node, job tracker, okay, and slave node has the task tracker, and the data node is the HDFS daemon. So the daemons for today, we'll be discussing about the daemons name node and the data node, that are the for the HDFS part. So HDFS stands for Hadoop Distributed File System, and okay, first move on to this. So HDFS stands for Hadoop Distributed File System, and I would first like to tell you how does it store the data. So I want to show you, draw some diagram and show you how this is actually, how the data is stored. So you know any file system like Unix file system, just a moment, drawing tool is not there. Okay, let me open the other thing. Okay, so supposing your hard disk has capacity of 500 GB. Okay, so what happens in hard disk? You know, it's divided into blocks. So generally any file system like of Unix file system you see, so it has the block size of say 4 KB. So that is the block size. So it is divided into, the hard disk space is divided into blocks, and the size in general file system I'm talking about, like a Unix file system. Okay. So there is a hard disk of a normal file system, so it will be divided among blocks, and the block size is supposing 4 KB. Now this HDFS is a type of file system, so it's lying on top of, it's actually a logical layer on top of your file system. Okay, so HDFS is a logical layer on your top of your file system, but the difference is that now the block size is not so small, because now we are dealing with big data, we are dealing with huge amount of data. So the block size now is bigger, and it's around, like supposing say 64 MB. Okay, so this is the block size. Now in HDFS the difference is now for Hadoop 1 I am telling, but for Hadoop 2 now the block size has increased to 128 MB. So the idea behind increasing the block size is that now we are dealing with huge amount of data. When you have small data blocks, okay, supposing your data is spread among these blocks only, so accessing these blocks is fine, but now we have huge amount of data and your file is supposing divided with a block size of just 4 KB, but your data is huge. So you can think of that how much IO is required to read the data every time. Okay, so it reads one block at the time. If the block size is small, how many times it will have to come and read, right? So now with Hadoop, with HDFS is a logical layer on top of your operating system file system, which creates for the user a bigger block size, so that it improves with the IO. We'll also see what are more advantages of having a bigger block size. Okay. So that is the concept behind HDFS, how the files are actually is divided among blocks. So HDFS is based on the design of Google file system, and this concept I'll tell you come up with. Now what is this? So we have two things, the master daemons, that is a master node, and these are the slave nodes. So this will be always a high-end machine. That will also see why, because this name node stores important information. And then we have the data nodes, which are these are the slave daemons. So these will be the cheap commodity hardwares in a cluster. Now what is these name node and data nodes they do? That also I'll explain you with example. So there is one farmer who produces rice. So he gets the rice packets and his production of rice is like this much. So he gets the rice packets and stores in his house. Okay? So what happens then, his production of rice increases so much that he's not able to store all his rice packets in his home. So what does he do? He goes to one godown manager and asks, please store my rice packets in your godown. So the godown looks something like this, supposing it has 6 rooms and they are numbered 1, 2, 3, 4, 5, 6. They are numbered in this way. Okay, 4, 5, 6. So these are numbered, and now the godown manager says, okay, there is a space in the room number 1, 4, and 6. Okay, so you go and keep your rice packets in the godown in these rooms. And what does the godown manager do? He has one paper where he writes down, okay, this farmer has kept his rice packets in these rooms. Okay, he has kept his rice packets in room number 1, 4, and 6. So he keeps all this information with him. And whenever this farmer approaches him again, he can just say, okay, these of the rice packets are now kept at these rooms. So this information is very important. Okay, and so what will happen if he loses this paper, if this paper gets lost? So this information is so important. If this paper gets lost, the whole information about where the rice packets of particular person are kept, that is totally lost. So this information is really important. So in Hadoop terms, we can say that we have something called name node, and these are the data nodes. So name node keeps the metadata information. This is something called, we can compare to the metadata information, the information about where the data is stored. So supposing we have a file, so file is divided among blocks, okay. So now these 4 blocks are divided, they will be stored at 4 different nodes. Supposing this is A block, B block, C block, D block. So A is stored on this data node, B is stored on this data node, C is stored on this data node, and D is stored on this data node. So this file which is divided among blocks, those blocks are divided among these data nodes. But name node keeps the metadata information, means the information where these blocks are stored. Okay, so it will keep the information. Okay, the first block is stored at data node number 1. Okay, this data node. So this is how it will store the metadata information. Now you can understand why name node should be a high-end machine, because it keeps the metadata information, and if this data node fails, or this name node fails, the whole information is lost. And data nodes, they store the actual data. They store the actual blocks of the file. So the chances of failure of data node is high because they are cheap commodity hardwares, right? So name node stores the metadata information, while data node stores the actual data. So name node is the master daemon, while data nodes are the slave daemons. Okay. So what do you think, what will happen if data node fails? So what do you think will happen if data node fails? So the data will be lost, right? Backup data nodes would be there, right? Deepjyoti, you're right. Something like that. There'll be, what HDFS does is that it replicates the data. So when file is divided among blocks, so one block will be replicated at 3 nodes. So if one fails, still it is present on other 2 nodes. So to store data reliably, HDFS uses data replication, that is by default 3. You can actually change the replication factor in the XML file as well. So we'll see how HDFS will support read operations of the file, but no updates will be there. So HDFS is implemented as block structure file system. Like for Hadoop 1, it's 64 MB, but newer version of Hadoop 2, it's 128 MB. By default, the block size will be 128 MB. So supposing your file is of size say 218 MB, okay, 218 MB. So if you have the block size, so there will be some blocks created 64, okay. So how many blocks it will be creating for 218 MB? Can you tell me? We have 218 MB file. So in how many blocks of how many size will it be created if the default block size is 64 MB? Can you tell me quickly in the chat box? Is 64 MB is the one, right? So 64 MB one block, then 64 MB one block, it will make 128, then 64 MB one more block. Okay. So 3 blocks will be of size 64 MB, and the last one, fourth one, will be of how much size? Okay, you can calculate that. So file is divided into blocks and then stored in the data nodes, and the block information is kept with the name node in the metadata information. Okay. So what is name node? It's a master daemon of HDFS. It maintains and manages blocks on name node, and it is a single point of failure. So what happens if data node fails? We have the replicas on other data nodes, but what happens if name node fails? So still till Hadoop 1, name node was single point of failure. Okay. So name node is the one who manages the block replication, and these data nodes from time to time, they keep sending block report and heartbeat to the name node that we are alive. So if in case name node doesn't receive any heartbeat from any of the nodes, it will assume that that is lost. So it will create the replica on some other node. Okay. So that is what name node does. It manages the block replication. If you have set in your configurations that replication factor is 3, so it ensures that your replication factor should not be less than 3. If it becomes less than 3, it maybe some connection is lost or the node fails, so it will quickly create another replica on some other data node. Okay. So name node is a single point of failure. Let's see that. Then data nodes are slave daemons. They store the actual data. They interact with client or read. So client contacts a name node that, okay, I want to read or write the file. The name node gives the information to the client that these file blocks are present on these data nodes. Then this will go and interact with the data nodes and read or write the files. Secondary name node, what does it do actually? So till Hadoop 1 I am talking about, what happens is that name node is the single point of failure. So there is something called checkpointing. Like secondary name node, what it does is a name node has has in its local file system, it has two files, edit log file and one is the FS image. Okay, so there are two files, FS image and the edit log file. So edit log file is a kind of transaction log file. So there are two files, FS image and the edit log. One is the edit log. So edit log file is kind of transaction log. Transaction log meaning if you are editing anything in the file system, like you're renaming a file, you're changing the replication factor or doing any operations on the file, then this edit log will note it down everything as a transaction here in the file. But the problem is that this file will grow so much because any operation you're performing, it will be written on this edit log file. So FS image file is the file which captures the current state of that edit log. So FS image is kind of taking a picture, the current picture of the edit log. So what secondary name node does is it merges these two files. It merges FS image and the edit log. So what happens when name node starts up, it will apply all the transactions from edit log to the in-memory replication of FS image and then flushes out this new version into a new FS image on disk. So this process is called checkpointing. So checkpointing always occurs when the name node starts up. So this is something was happening in Hadoop 1. So secondary name node job is to merge these edit log and name node and time to time have the update of the check, means this is updated now. But still there is a time lag between secondary name node and name node. There is this name node is still the single point of failure in Hadoop 1. So if it fails, what happens? You have to restart it manually with the FS image in the secondary name node. You have to restart the name node. So it's manually admin has to do. So this is the admin job to take care of these nodes are running properly or not. This is all taken care by the Hadoop admin. So secondary name node just helps in the backup checkpointing, but ultimately still the name node is still considered the single point of failure. So this metadata information that is stored in two parts, FS image and edit log. So this is actually recovered, but the single point of failure was name node till Hadoop 1. Now what happened in Hadoop 2? In Hadoop 2, name node is not the single point of failure. Now we have one more name node. Now at the same time, two name nodes work. One will be active, one will be standby. So if active fails, then standby will take over as the active node. Okay, and so there is no need of manual intervention to actually restart the name node, which used to take time. Now the active will also have all the block report and heartbeat from the data nodes, and it will quickly take over once the name node fails. So that is called the high availability feature in Hadoop 2. So now the name node is highly available with the version Hadoop 2. So this is the HDFS architecture. What we see is that, okay, supposing this is a file that is divided among blocks. The client contacts the name node. Okay, name node has already stored the, if you want to write, now client wants to write the file. Okay, first it wants to write the file to this data nodes. So it will say, okay, these data nodes you can write the data to, and what will name node do? It will write, it will tell the client will write the data to particular data nodes. So you can see, if, supposing it has written 1, so 1 will be written on data node 2, or it can be written to again another third data node if the replication factor is set to 3. So it will create 3 replicas, and this will be done in a pipeline fashion. So it's not that it has to come and again write, it will automatically be written in a pipeline form. And this information is then sent by data nodes to the name node that this is present, and name node will store the every block in metadata information that there will be a mapping, there will be a namespace here of all the files that are stored. Then for reading, again the client will contact the name node. Name node will say from the metadata, okay, these blocks are stored on these data nodes. Then client will go and access there and read the information, the block which is nearest to it. So that is also given preference. So it will read the nearest block and then the other one. So these data nodes keep sending heartbeat and block report time to name node. If they, supposing this data node doesn't send heartbeat, then name node will understand, okay, this has failed. So instead of 1 here, it will create a replica on some other data node. So is that clear, that much? We have some XML files that I'll be showing you. You can do some configuration there. Any questions till now? Yes, Ovik, we are using Hadoop 2 now. Hadoop 1 I have to explain because we have switched from Hadoop 1 to Hadoop 2. So we should know what were the disadvantages with Hadoop 1 that came with Hadoop 2. So little bit knowledge about both the versions is good. So now currently we are using Hadoop 2. Hadoop 3 has also come, but we are using Hadoop 2 for now. So Vidra is asking, how does HDFS reduce the data discrepancy risk since the data is replicated in multiple data nodes? So they are kind of in pipeline, they are written to each and every data node. Okay, so the data will be same. Is that what you were asking? What kind of data discrepancy you are talking about? Yeah, they are written in pipeline fashion. So same data will be written across the 3 nodes. It's not that again the same data. So bigger picture will be like means it will be writing that in a pipeline fashion. So that won't make the data different. So at the back end, it's all, if you know Java, you must be knowing the file system. So this means the file system class you create and the objects you create. So similarly, here also at the back end, the distributed file system object, they will do the, at the back end, there will be some a data input stream, output stream that will be handling the communication with data nodes and the name nodes. Okay. I didn't explain the higher level thing about the using of distributed the Java part. That you can look into the document and know better. So Deepjyoti is asking, could you explain once in short? Yeah, at the end of the session, I will give a quick revision of that too. So now we have these three files that we'll be talking about. We have core site.xml, then we have HDFS site.xml, and these are some of the configuration files that is actually taken care by the Hadoop admin. So there is one file, Hadoop environment.sh. So this is the file that specifies environment variable that affect the JDK used by Hadoop daemon. So as Hadoop framework, you know, is written in Java and it uses Java runtime environment. So one of the important environment variables for Hadoop daemon is Java home. So the variable will direct Hadoop daemon to Java path in the system. Then we have this core site.xml. So this file informs Hadoop daemon where name node runs in the cluster, the address of the name node. It contains the configuration settings for Hadoop core such as IO settings common to HDFS and both MapReduce because it's the core site.xml. So host name and port number are the machine and the port on which name node daemon runs, that it gives the address there where it is present in the cluster. Then we have HDFS site.xml. So it will, this HDFS site.xml, it stores the configuration for the name node, secondary name node, data node, and it also stores the default block replication and also the replication factor. Means the blocks are 64 MB that you can set here, and replication factor also, if you want to change, you can do it in HDFS site.xml. Okay. Quickly, I can show you these files where they are present in Cloudera. So people who can't install Cloudera, they can actually go to Hadoop document and install Hadoop. Okay, there at least you can work on HDFS and MapReduce. Let's see what's there in code site.xml. So this is the core site.xml. Here you can see the name node address is given. That is the whole path. HDFS quickstart.cloudera as the IP address and host name. This is the host name, and this is the port number 8020. That is for the name node. So this port number you can see here also in Hadoop name node. So this is the IP address and the port number. Okay, this is our name node. Okay, so this is core site.xml. As a developer, you need not dig deep into it. As an admin, you need to know these parameters, these property settings a lot. Similarly, here you can look into the HDFS site.xml as well. Okay, so there HDFS site.xml is there, Hadoop environment.sh file is there, then for MapReduce site.xml is there, and now after MapReduce yarn has come, so this yarn site.xml has also come. What is yarn? We'll talk about that later. So today we have to finish with the HDFS part. Okay, I want to talk about rack level awareness. So what is this rack level awareness? You know, we need to place the replicas of blocks on 3 nodes. But how to place it? So by default what Hadoop does is, it places 2 replicas on one node and the third on the other node. So supposing uh, 1A is here and 2 A's are on another rack. So rack is, you can think, is a collection of all these nodes, and when rack level awareness means that it knows that one replica will be on one rack and other two will be on another rack on different data nodes. So what if we place all the 3 replicas on the same rack, so if one rack fails, then all the data will be lost. So this is how we actually store the data. Okay, and then why not on the 3 different racks? Because again it will create a lot of network traffic. So there will be, when they are on 3s and while reading, it will have to have a lot of network issues. So large Hadoop cluster are actually arranged in racks, and they place replicas of block on multiple racks for improving the fault tolerance. So they will never lose all data if entire rack fails. You can define this by user defined script. So local file system and HDFS commands we can talk about little bit if you know Unix. So simple local file system and HDFS commands we can run from here. Just open up the terminal. If you want to list the files, you can see the extended list of the file. Okay. So local file system commands are similar to Unix file commands. So you can actually create a file. You can see the list of the file. You can see the present working directory. So by default we'll be working in /home cloudera. That is our present working directory. ls will list the files that are present in your local file system. So here we have two things. One is the local file system and one is the Hadoop distributed file system. So it's you can see, if you do not know Unix, this is how you define if it's a directory, a D will be written, otherwise the rest are the files. Okay. This is a directory, and these are the read, write, execute permissions. We can make a directory, then we can create a file. So you can create a file using either the cat command, where you can write okay. So you can create a file using cat. Then you can also use VI editor. Okay, this is a VI editor. Escape :WQ. This will save it. You can also use gedit to create a file. Okay, this is better because here you can easily edit the things, and simple text editor kind of thing. Just edit it and create a file and change it. Okay. You can do a word count. So there are a lot many commands if you know Unix, like copy, cp, renaming the file, movie, mv, rm. Then you can just remove this file. Okay. You can also use chmod to change the permission. Then if you know the tailf command, commands of Unix that you can use here. If I want to list the files present in HDFS, I will be using Hadoop FS ls command. Okay. So this will list the files that are present in HDFS. Now, if I want to put my file from local file system to HDFS, I will be using Hadoop FS put command. And to see the files here, first let me show you. I want to look into some directory, or I want to do this cat on file 1. I can use the Hadoop FS cat command to see the contents of the file. Okay, now supposing any of the file I want to put from from the local file system to HDFS, I will be using Hadoop FS put command. Okay, so you give the path of the file, any file, let us take Sajid, you are having some internet issues? Meanwhile, I have one question for you people. The small files you want to get into HDFS, or means lot of files of small size, or less number of huge files, means big files. I didn't get you what Supriya is asking till now. What we learned, that is admin related task. Yeah, but accessing the files, like we are doing the hands-on on accessing the Hadoop files and local file system, that obviously that needs to be done by developers. So those XML files, that means those Hadoop's HDFS site.xml, core site.xml, the configuration files what I have shown you, they are actually handled by the admin people too. Means admin, what it does is it takes care that name node and data nodes are functioning properly. And what means name node is there, like if there are no dead nodes in the cluster and something has not been found out, and if maybe if the system is slow, he wants to check by creating the more number of by increasing the block size or improving the replication factor, increasing the replication factor. So that can be that will be done by admin. So he takes care of how the system is running, the speed and everything. The admin takes care of all that. I think there is some network issue. This meeting will end in 5 minutes if it doesn't resolve. Let me check with Sajid. What is the problem? Okay, meanwhile I have one question, like if you have large number of small files and small number of big files, large files, so which is better to be stored in HDFS? Can anybody tell me? After what we learned about block size and everything. So can you tell me that if we have a large number of small files to be stored in HDFS and there are a small number of large files, so which would you choose to store in HDFS and why? Meanwhile, I'm sharing one comics that will make your learning interesting. Anybody would like to answer this question? This is a comics link and large number of small files. You will choose. Why? Means you want to store large number of small files in HDFS. Actually, if there are large number of files, you know, when you divide those files into blocks, so you can think how many, so many blocks will be created, right? So the namespace information will be, that name node will be loaded with the information. So metadata information, it has limited memory, right? Name node will store the metadata information in its memory. So that has limited memory, right? It's a machine anyways. So it will be overflowing with the information about the blocks. So we will not prefer having a large number of small size because there will be lot many blocks that will be created and so many mapping has to be done in the namespace information, metadata information with the name node. So it will be like name node will be overflowing. So if you have small files, you first need to actually merge them and then get into the HDFS. Is that clear to all of you? And this is a link for a cartoon, HDFS cartoon. Like this will really make your understanding very clear. So it will tell you in the form of this cartoon, it will explain the what is block and replication, how it communicates with the name node, okay, how the replication pipeline is created. So it's explained in very nice way. Once you read this, you will have the good understanding of everything what I have taught you today. What is the rack awareness, how the replicas are stored, and see, this also I will just send you the link. So all documentations are present online. You just need to work into it. So please look into this document. You'll see that these are the commands that are present you can use. So Hadoop FS, cat, I just showed you how to use it. Okay. Then others I won't be running all, so you can just check the document and do it. So I was talking about this Hadoop FS get and put command. So Hadoop FS get is used, it copies the files to the local system. Supposing you, whatever files you have in HDFS and you want to copy to a local file system, you will be giving Hadoop FS get and the path of the file present in HDFS and then the name of the local system file you want to store with. So that way, please try these commands, Hadoop FS get and put commands. Okay. Hadoop FS ls I just showed you. Then you can also use Hadoop FS make directory. Then this is the Hadoop FS put command. RM. RM is for the removing the file or the directory. RM directory is for removing the directory. And RMR you use for recursive version, means when you want to delete the file with directory together. Okay. And one more is this set replication. Like I've already told you that you can change the replication factor in the XML file. But there is one more method, that is Hadoop FS set replication -w3, and you can particular file you can change the replication factor using this command -setrep. Okay. Then there is one discp command. This is very much asked in Hadoop interviews, that what is discp. So discp, it's not coming here. So Hadoop discp command is actually used to copy in a distributed manner, means from one cluster to another cluster. If you want to copy a file from one cluster to another cluster, then you use discp command. So discp actually it will copy the file. You have to give the name node location of one system, and then the other one that will copy the file from one name node to other name node, one cluster to another cluster. Okay. So Hadoop FS tail command, it displays the last kilobyte of the file to your output. So you have to actually little bit work on your own. You have to do some hands-on with this to practice all the Hadoop commands. Audio? Are you not able to hear me? Okay. Any questions? Okay.
Thank you.
Okay, thanks. Any other question? system. Okay, this we are talking about when it's not Cloudera. Cloudera is actually a distribution device that is getting all together. But without Cloudera, you can just download Hadoop, okay, on your system, Hadoop libraries, and this is what is called a sudo mode. Then you update the configuration files using a SSH and SCP copy Hadoop folder in the cluster. This you don't have a cluster, you have one node. Supposing you have a cluster, then you will be updating these files on the other nodes as well. Then what you'll do is, see this, you have installed Hadoop folder on all of these. Then you start the of that is Hadoop storage layer. So relational database will talk about what, how Hadoop will help you doing those queries that you do in relational database. But this is just about the storage part. Got it?
Yeah, fine. Thank you.
This picture would have made things clearer. So I was just opening these files to make you. This is the high level block diagram. You can see 1, 2, 4. So it will be divided into these blocks. These will be stored here. So after this, when you log in as the user, then you have to just say start dfs.sh. Okay. Today's session, this much is fine. If you have any questions, you can please mail me. If you have any queries, and for the reference of it, for the theory and for the lab part, you can refer this talk.